Hello. So this is actually my first ever ASMR video, and for that reason I decided that I wanted to keep this study session super simple and super light. So for that reason today we're just going to be going over the 20 common amino acids. And as I'm still figuring out my setup and everything, please don't refrain from letting me know in the comments how you feel, if you like this angle, if you like the setup, how you feel about the mic. So what we're going to do today is we're going to go over the 20 common amino acids. And actually before that, we can really quickly do just a quick recap on what amino acids are and their structure. So essentially, we know that these tiny molecules are the building blocks of proteins. And we know that we require proteins for enzymes, especially to catalyze reactions, to build and repair cells, etc. So proteins are super important, and you can think of each amino acid as a sort of individual brick or individual block in this structure that is a protein. So of these 20 standard amino acids, they all have the same rough structure, which is we have more basic structure, you could say. We have a central carbon that is connected to our carboxyl group. And then it is also connected to an amine group. The central carbon also has a hydrogen. And to fulfill this octet rule that we have going on with the central carbon is we have our R group. So take a closer look at that. Again, we can see on this side, we have our carboxyl group. On this side, we have our amine group, or just an amine. And then of course we have the hydrogen and the R group. And so commonly you'll just hear this be referred to as the R group, but you can also think of it as the variable group. So what I mean by that is all amino acids have these three substituents or things connected to that central carbon, and the R group is what varies and makes each amino acid unique and have its own different properties. So now we're going to get into the 20 common amino acids, and what we're going to do is we want to consider the structure and how this applies later to grouping or categorizing our amino acids, because you'll see that depending on their R group, a lot of them can be very similar, which means that they can act very similarly within a protein or a polypeptide. So we'll look at their structure and we'll take note of their R group. We'll have their name, their full name, but then we'll also do the 3-character name and the single or 1-character name. Now, it's important to memorize all of these because it really depends on your professor's preference and whatnot, but a lot of the times these amino acids will get shortened to either their 3 or single character name, so it's really important to know all of them. Okay, so let's move on, and we'll start with some of the most basic amino acids, right? So first off, we have glycine. Now, this one is shortened to GLY, GLY, I suppose, or just G. Pretty simple. Most amino acids tend to follow this sort of pattern of where it's just the first 3 letters or the first letter, but you'll see that that's not always the case. So again, important to memorize. So our glycine, if we start at our central carbon, we can go to our carboxyl group. Make that a little bit easier to see. And then a lot of the time, depends on how you'd like to drive, but a lot of the times I'll go down with my amine group. And then this one, its R group, is actually just another hydrogen. So, the interesting thing about glycine is that it is the only amino acid that does not have a chiral carbon, which also means that it does not have unique R or S stereochemistry. So that's something to watch out for. I know we had professors try to trick us and say, oh, let's figure out what this amino acid is based on its structure, and then figure out, its stereochemistry. And sometimes even these really basic amino acids will get you. So that's glycine. Another thing to note is sometimes you will see amino acids drawn in their Zwitterion form, which is just where, if we draw the same structure again, we have our hydrogen on the R group, and obviously the other hydrogen I'm not really drawing, but it's there. But then a lot of the times you'll also see it drawn like this, where on the carboxyl group it'll get deprotonated and the amine will steal that hydrogen, but same amino acid, and we're not really talking about their ionization states or anything. But our next one is alanine. Again, ALA or just A. Now, this is the next most simple amino acid, again, our basic carboxyl and amine group, and this time instead of a hydrogen, it's just a methyl. So it's just connected to another CH3. About as simple as you can get. A lot of people will also draw them with the amine and the R group flipped, which can actually make it much easier when you're drawing full polypeptide sequences. Because then you get the N terminus and the C terminus, so it's really probably better to do it this way. But anyways, next we'll move on to valine, VAL or V, and this one we get gonna connect to another carbon, and this one branches off into 2 more carbons. So if you wanted that full drawing, I suppose, it would look like something like this. Sort of not the best for showing the actual angles, but you get it. Next, we have, I'm going to go to leucine, which is LEU or L. And this one is just similar to valine, but it's 1 carbon longer. So you get 1 extra CH. This becomes a CH2. So just 1 more carbon added before you get the branching. And then similarly named, we have isoleucine. And this is the first one that's going to be a little bit less intuitive. It's ILE or I. And now this one looks somewhat similar. We're going to have a carbon chain. I'll try to make it look a little bit better for you. We're going to have a carbon chain of 1, 2, 3 carbons. It's not the best chain, but we'll work with it. So 1, 2, 3 coming off of that center carbon, and the first one will also have its own little methyl group. So you can see these are all quite similar, as they're all really just short carbon chains, and we'll actually talk about how that relates to grouping later, but very subtle differences you can notice. Now getting into some more of the more interesting amino acids, I would say. Next we'll do cysteine, which is CYS or C. Back to that similar pattern. And now this one will be our first time breaking away from just carbon chains, you're gonna have one CH2 and then SH, a sulfur that is protonated. Then we'll do proline, PRO, pro, P. Now this one you might have to bear with me because it's a little bit harder for me to draw. But start with our carboxyl, and then we're going to draw it H2. We have another carbon, and then it just comes around to make this 5-membered ring with the amine on it. And because of this, the amine also becomes positively charged. So then we have, this one's more similar to cysteine actually, but we have methionine, MET and M, pretty intuitive. And now this one, we're gonna have 1, 2 carbons with a sulfur and then a methyl right off of it. So essentially very similar to cysteine, just replacing that hydrogen on the sulfur with a methyl. Next we have tryptophan, which is TRP or W. Really weird. I think TRP makes some sense because if you, I guess, shorten the initial part, TRP still kind of sounds like trip. But the W kind of comes out of nowhere. But anyways, this one I'm just looking at my notes. I also just realized our amine loses a proton, I believe. So it's actually not charged. Now it would be the NH2 plus if we remove the proton, the OH. So, pardon me there. But back to tryptophan. We're going to take a methyl, or just 1 carbon, and that is going to branch into, again, you'll have to bear with me for a second. Gonna look something like this. A little bit difficult to see there actually. But then so you'll have 1 5-membered ring with another nitrogen in it, and then a 6-membered ring, which is actually a benzene, because it shares this double bond with a 5-membered ring. So there we go. And then the last one, which is a lot more simple than that one, phenol think is a little bit easier because it makes an F sound. And this one, another carbon that is then just connected to, I did not give myself enough room to do this, but phenyl group. So the reason I did all of these first is because this whole group rounds out our non-polar amino acids. So you can see all of these are pretty much comprised of mainly carbon R groups, carbon chains, carbon rings, which again we know not super polar, or are fully protonated sulfurs that have their full octet. So now that is also the most substantial group of amino acids. So now we'll move on to our, let me pick a different color, our polar amino acids. So you can already kind of start assuming what we'll see here. But to start, we have serine, which is just SER or S. Pretty easy. And this one is just connected to a carbon, is then connected to an OH group. So you can already sort of see where we're going with this, because that's going to be super reactive in water. And then, or it's going to have it's going to have a strong affinity for water. Then we have threonine, which is THR or T. And this one's pretty similar to our serine, carbon, and an OH, but there's an additional methyl there. Super similar. And even though we still are sort of forming what looks like a carbon chain, this oxygen's still going to be quite polar. So then we have tyrosine. This one is TYR or tear, and Y. And this one looks like this. We have carbon, which is then connected to, did not do a good job of drawing that, a fully conjugated phenyl, and then across here is an OH. Again, very non-polar section, but then a very polar other section of the R group. Second to last in our polar section of amino acids, we have asparagine, which is ASN, or this one carbon, and we're going to get an amine. Off of this carbon, we're also going to have a double bonded oxygen. And then lastly, to round out our polar group, we have glutamine, which is Gln or Q. Now I don't know where the Q came from. I guess we ran out of letters, but I think from the name you can already start to understand that there's probably going to be an amine group in our group, and you'd be correct. So this time we have 3 carbons on our chain, and that last carbon is connected to an amine. Once again, double bonded to an oxygen. So very similar to the last one, just an extra carbon in that chain. And that 5 rounds out all of our polar amino acids. Lastly, our last 2 groups of amino acids are separated by charge. So first we're going to do our plus charge amino acids. The first one is lysine, which is OIS or K. And these are where the chains start getting a little bit longer. Not necessarily more complicated, just longer chains, right? So we're gonna have 1, 2, 3, 4 carbons in our R group, and then we're gonna have NH3 plus. So I told you we'd have that plus charge, but technically this whole thing is the R group. Next we have arginine, which is ARG or R, which again, I think that one's pretty intuitive. Similarly, we're going to have a pretty long chain, at least long compared to the rest of the amino acids so far. We have 1, 2, 3. 1, 2, 3 carbons before connecting it to a nitrogen, and another carbon, which is connected to this amine group. This nitrogen has to have a hydrogen on it. And then our last carbon is also double bonded to an NH2 plus. Lots of nitrogens going on, but there's our plus charge again. And lastly, we have histidine, which is HIS and H. This one we have a carbon, and this carbon is going to be part of a 5-membered ring. I'm gonna go this way with it. Not the best drawing, but we will have double bond there, and then this one also going to get a double bond, which is going to make it positively charged. Now, lastly, because, as I said, they're separated by charge, we're going to have our minus charge amino acids. And we just have 2 of these. Our first one is aspartic acid, ASP or D. And this one we'll have 1, 2 carbons, and this last carbon is connected to another carboxyl, or deprotonated carboxyl. So, pretty much mirroring each other, really. And then our last is glutamic acid, which is GLU or E. And this one is fortunately super similar to aspartic acid. It is just 1 carbon longer. So instead of having 2 carbons connected to that central one, you have 1, 2, 3. And that third one is part of our negatively charged carboxyl. So as I promised, there are our negative charges, and those are all 20 amino acids broken down by their structure and how they're grouped together, and their full 3-character and single character names. So I hope you enjoyed, I hope you learned something, and please let me know what else you would like to see in the future. Have a good night or a good rest of your study session.